Hi guys, these are your notes for section 10.5. Today we're going to talk about sines and cosines and how they're related to each other. The first chart, I would put my notes, but I want you to realize that you don't need to memorize this at all. We did this in the section previously. Where's my pen? Here it is. Okay. How can you determine if the sine or cosine is going to be positive or negative? Well, here, the x and y coordinates are both positive. So it's positive, positive. Here, if your angle was in this region, be negative, positive, negative, negative, positive, negative. Just because cosine is the x-coordinate, sine is the y-coordinate. Once again, that's really important information. It will tell us, just by given the angle that we're looking for, if you're going to have a positive value or negative value. It's very, very, very important that you're going to be reflective on this, because most of the time when we figure out these problems, we're going to change these degrees, like from 180 to 270, to something in an acute angle, because we're dealing with a triangle so that we can see it better. And if you type it in your calculator, it's going to assume it's in quadrant 1 even though it's not, and it will give you a positive value. So you really need to be reflective and say, where was that triangle to begin with? Is the sine and cosine positive or negative? So let's talk about these. Cosine of 212, where would it be? Well, 180 is here. 212 would be about here. It's about 212 degrees. Cosine, we're looking at this point, xy. Cosine is x. X in this case would be negative. What would the sine be? Sine is also going to be negative. Cosine of negative 17 degrees, where's that? Well, we're talking about here, 17 degrees. So we're talking about quadrant 4. Cosine here, when we're talking about xy, x value is going to be positive. Your y value here will be negative. If you type them in your calculator, yes, you'll get the right answer, but it's just really important to actually maybe draw in that reference angle so that you know what you're talking about. Okay, this will be useful on the ACT. They almost always throw this trig identity in there. You're going to learn lots and lots of identities next year in trigonometry. And what an identity is something that is always true for all variables. Okay, this first one's called the Pythagorean distance formula. It comes from that, so it's called the Pythagorean identity. This should make sense to you. When we're dealing with the unit circle, we're dealing with lots of right triangles. So we use the Pythagorean theorem in those right triangles. Remember, that was your x value and this was your y value. Cosine is x. X squared plus y squared in this case will always equal 1 squared. Okay, this is the Pythagorean theorem. A squared plus b squared equals c squared. 1 is my hypotenuse, because we're doing with the unit circle where the hypotenuse is 1 because the radius is 1. So, always and forever, cosine squared plus sine squared equals 1. A lot of times kids say sine squared plus cosine squared equals 1. It really doesn't matter. Truthfully, you should go ABC order because that reminds you where it's coming from. Dx squared plus y squared equals 1. But either way works. This needs to be put into your memory. So let's look at an example. They give us a circle that kind of looks like this, except they're telling us that the angle is not 28. They're going to give us an angle of 52. So I'm going to kind of white out this. Look at that. That's pretty fancy flip chart work right here. You can save your oohs and ahs for later. We're going to put a 52-degree angle in here now. And they want to know where point C is. They want us to approximate it. Well, we just talked about this yesterday. We're talking about cosine of 52, sine of 52. Because the x goes with cosine, the y goes with sine. They don't want exact, though. They want us to approximate to the nearest thousandth. So I'm going to go ahead and type it in my calculator. Cosine of 52, I get 0.616 approximately. Sine of 52, I get 0.788 approximately. They're both going to be positive because we are talking about an angle in quadrant 1. They want to verify that's true using that Pythagorean theorem identity that we talked about. So I'm going to do 0.616 squared plus 0.788 squared. And what do I want it to equal? Well, I want it to equal the radius squared, or the hypotenuse squared, in this case, which is 1 squared, which should just be 1. Type it in my calculator. And I get 1.0004 equals 1. pretty close here. Okay. If I would have typed the exact value, cosine of 52, enter, squared, if I didn't round, plus sine of 52, closing parentheses, squared, I get exactly 1. Your calculators know what they're doing here. Just make sure you type them in properly with parentheses. Okay, let's talk about the relationships between like cosine of 150 and cosine of 30. You need to keep in mind the symmetry of a circle. If I reflect over the y-axis, these 2 points would map on top of each other, okay? But when we're talking about coordinates, in this case, cosine of 150 is going to be a negative value. Sine of 150 is going to be the same. So sine of 150 and sine of 30 will be the exact same values. Cosine of 30 and cosine of 150 will be opposite values because this one is positive, and this one is negative. But the values will be the same because of symmetry. When I drop this in, they would fold on top of each other. They are congruent triangles. You can get exact values on some of these if you use your special right triangles, the 45, 45, 90. Oh, that's a 4. Remember the legs are like x, what's that, x root 2, I think. I just wrote it down to make sure I didn't mess it up when I told you guys. And the 30, 60, 90, if this is x, this guy is 2x. There's something about root 3 in here. I don't remember. I need to look that up to tell you. But I don't have it with me right now. I don't think it'll come up. If it does, it'll come up on your homework. I'll give it to you tomorrow. We'll write it on the board. I could figure it out if it comes up on a problem here, but I don't think it does. I was right. X root 3. Okay. Moving right along here, let's talk about third quadrant values. These, this always confuses me, this theta equals 180 rule. I always draw a picture. I need to see it to know what's going on. When I read this 180 rule, it confuses me, but as soon as I draw a picture, I'm like, oh, that's where it's coming from. Basically, what they're saying here is if you take an angle that's in this third quadrant, this is talking about third quadrant angles, if you subtract 180, it will tell you what I call the reference angle is going to be, which is the angle of your right triangle that you're going to be dealing with. So the example is here, sine of 222. 222 would be about here. If I take 222 minus 180, I get 42. So that's saying that this angle here is going to be 42. Well, duh, because that's where it is. It's 42 degrees past 180 mark. I just for some reason don't think, oh, third quadrant, subtract 180, until I draw the picture though. So what they want to do is they want to show why this is true. Sine of 222 is the y value of a 42 degree angle here. It's going to be negative, and the reference angle is 42. So because that reference angle is 42, because when you take 222 and subtract 180, they will be the same. That negative in front is just saying it's going to be negative here because it's in quadrant 3. This guy's in quadrant 1. So show why cosine of 252 equals negative cosine 72. Well, cosine 252 would be down here. If I drew in my right triangle, to figure out what this angle, let's call it alpha this time is, I would take 252 minus 180, because I went 72 degrees past 180, so that's what that angle is. Okay, both values here are negative because it's in the third quadrant, so cosine of 252 should be the opposite of what cosine 72 is, because that's in quadrant 1 where everything is positive. Okay. Fourth quadrant values, excuse me, I have fourth quarter on the mind, can reflect over the x-axis here. Okay, again, you're keeping in mind sign changes that will happen. The x values would match up, the y values would be opposite of each other. They want an exact value of cosine 315. Okay, so what we have here is 315. I'm going to take 360 minus 315 to tell me what the angle I'm dealing with here, and that makes it 45 degrees. If I drew in my right triangle here, excuse me, I know that this is one, it's going to be an isosceles triangle. So this value is x. Instead of throwing a y in here, I could throw in x again if I wanted to, because they are going to be the same. Basically, if I'm looking for, cosine. Sorry, we're looking for cosine, which is the x value. I'm going to solve for x here. To figure out what that is, I could do Pythagorean theorem. X squared plus x squared equals 1 squared in this example. That's 2x squared equals 1. Divide both sides by 2. X squared is 1/2. But when I square root both sides, I have the square root of 1/2. I'm going to go up here now. That's the square root of 1 over the square root of 2. You cannot have a square root in the denominator of a fraction, so we're going to rationalize here. Multiply top and bottom by square root of 2, and I get root 2 over 2. That's my value for x here, which is the cosine value, but it's also the value for y, so it's also the sine value at this point. So this point is root 2 over 2, root 2 over 2. That will be something you will memorize. Your 45-degree angles are the same, and it's root 2 over 2, and it comes from the special right triangles, the isosceles triangle qualities of those. It should be an easier one for you to memorize, and a lot of kids just memorize them. We'll talk about the 30, 60, 90 a little bit later. Where's my... Okay, here's an example of that. Find an exact value for sine of 330. Okay, sine of 330 is going to be right here. 30, 60, 90 triangle. I don't need to do the root 3 part of it. We know the radius is 1, and we also know that in 30, 60, 90 triangles, if this is the short leg is x, which this would be the short leg here, the y value that we're looking for, so I shouldn't call it x, I should call it y. This would be twice a y. So if this is 1, what is its y value? That's going to be 1/2. Sine of 330, though, is going to be negative here because we're going down, so it's negative 1/2. I don't think you're dealing with the root 3 ones today, but we'll look it over in the homework. Your homework is on page 692, 1 through 28, and that's what we'll get busy on in class tomorrow. Thanks.